Everyone, welcome back to another exciting day in mathematics. Warm-up 83 should come up as soon as you log in. Let's get started, please. You will need a calculator. Problem number 1 says sketch a bell curve. Also compute the z-score of 30 and check for outliers given 32, 10, 20, 50. And for number 2, compute 9 factorial. Get started, please. We don't have a lot of time. We are moving on today. Go. All right, here we go. Mean, Leshka, what'd you get? $22.4. Hands, have you got that? That is correct. Standard deviation. Pass on one, Aleshka. Clearing, what you get approximately? Approximately what? Amelia, what you get? Okay. $18.6. All right. Hands, if you got something like that, looks about right. So therefore, our standard deviation up, we should be at 41. And one below should be at, let's see, 3.8. Is that correct? Yeah, right? So between 3.8 to 41. Now we need a z-score for the number 30. Z-score for 30. All right, pass on one, Amelia. Alexa, z-score for 30. 0.4. So if we go to the right of the mean, right before the half, is 0.4. Looks about right. All right. However, it's to check for outliers. Small outlier, large outlier. So, small outlier, quick formula is Q1 minus 1.5 times IQR. Large outlier is Q3 plus 1.5 times IQR. All right. So with that said, pass on one, Alexa, for the small outlier. -75 for small outlier. Okay. Hands, have you got something like that? Let's double check. Q1 was what? 6 minus. What was the IQR? 34. So 34 times 1.5 gives us what? Close. Isn't it 51? Okay. 51. So the small outlier is 45. Oh, and it's a negative. Sorry. Negative 45. All right? So, large outlier. Pass them one. Pass to who? To me? Let's go. Q3 was 34 plus 51. Large outlier we need to check for is 85. So that means we don't have any of each. So no small outlier, no large outlier. 9 factorial. What'd you get for 9 factorial? I get to pass this to, how about Austin T. What'd you get? Nine factorial? To who? Cole. Did you get for 9 factorial? All right. Austin S., what'd you get? 362. 880. Hands, have you got that? That is correct. How do we get the factorial? What does that mean? That means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you just multiply all the numbers from that number all the way to 1. And that's how we get this. All right, send that in, please. Copy the agenda. Warm-up number 83, conditional probability. We're moving on today. And tonight's home plate, only one problem, one itty-bitty problem. Thank you, Mr. Q. You're welcome. I got you. Oh. Gonna get windy, guys, all week. So make sure, once again, even though the cold weather is almost out, this week's gonna cool off a little bit. But I think for the rest of February, it's gonna warm up to like the 80s. So those of you that are very that have allergies and stuff, so make sure you up your vitamin C and all that. Spinach, kale. You guys know what that is, kale? Yeah. It's just greens. Like, eat a lot of greens with your salads or sandwiches. Thank you. You're welcome. All right. Copy the code for access to the home plate, RVDN2. 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 All right. Hopefully you guys had fun over the weekend. Super Bowl weekend, yeah. Some of you are like, you spend, instead of watching that, you spend time studying your formulas. Very good. Appreciate it. Got you. All right. So, with that said, to get a Cornell note going, please. Let's get this show on the road. All right, here we go. I can identify and compute the basic probability. So we're still in the middle of that, guys. We've been through 3 weeks now with probability. We started with our definition, a chance of an event occurring. We know the difference between classical, empirical, and subjective probability. From there, we went to events. We talked about mutually exclusive, non-mutually exclusive, which gave us 2 addition rules, addition rule number 1 and addition rule number 2. Is that correct so far? Yeah? From there, we went to more events called independent and dependent events, and which gave us the multiplication rules that look something like this. Multiplication rule number 1 and number 2. Which brings us to today. Copy the new rule, please. It's on your screen. P, B given A equals to P, A, and B over P of A. Don't copy the verbiage, just copy the rule. Make sure you label it formula for conditional probability. Conditional probability, that means a probability will happen depending on certain conditions. So here it says the probability that a second event B occurs given the first event A has occurred can be found by dividing the probability that both events occurred by the probability that the first event has occurred. There's a formula. Now, like I said, don't worry about the verbiage. I'm going to explain it by applying it to a problem, which is fairly simple and straightforward. Just copy the formula. And as you're copying the formula, remind your neighbor what this bar stands for. This bar right there. The bar right there. What does that bar stand for? Right. Looks like Carter remembers. What does this bar stand for, Carter? Cole, what does this bar stand for? Brandon Doherty. What? To who? Very good. Dependent. Dependent. This should read P is B dependent on A, because once again, now we're looking at probability that is conditional. Something needs to happen before something else. However, for the purpose of today, look up. Whenever you see this bar, remember the word, look up, the word given. Label that on your formula, given. Because we're going to be looking at word problems, and we're going to be applying this formula right here. All right? Given. All right? So, with that said, let's go to the next problem. Copy the verbiage on this one. You do need to have this one on your notes. And it reads, example Q. The probability that Sam parks in a no parking zone and gets a parking ticket is 0.06. And the probability that Sam cannot find a legal parking space and has to park in a no parking zone is 0.20. On Tuesday, Sam arrives at school and has to park in a no parking zone. Find the probability that he will get a parking ticket. Copy the whole thing, please. I'll give you some time. Go. All right, here we go. Whoa. Let me zoom out. All right. So, to get started, let's set up our formula first. We got P of B given A. P of A and B over P of A. All right, in order to set up our formula, guys, we need to substitute values. So let's leave blanks. And in order to set up our formula, we need to look for keywords. One keyword we said was the word given. Is that correct? However, let's read the problem and see if we can see that word in there. It says the probability that Sam parks in a no parking zone and gets a parking ticket is 0.06, and the probability that Sam cannot find a legal parking space and has to park in a no parking zone is 0.2. On Tuesday, Sam arrives at school and has to park in a no parking zone. Find the probability that he will get a parking ticket. Question, do you see the word given? No. However, the second key word that I want you to look for whenever they give you a word problem is the word and. And. So, circle the word and in your notes. There it is. And that's going to help us to set up our formula, look up, because we have the and here on top of the formula. You guys see that? A and B. You guys see that? Right? So here's the and right here. The and is right there. So we need a letter for whatever came before the word and a letter for the word or anything that came after and. So it reads, the probability that Sam parks in a no parking zone. So before the letter and, we're looking at no parking zone. I'm going to use the letter N. Letter N for no parking zone. And then it says, and gets a parking ticket, comes after the word and, gets a parking what? Ticket. So I'm going to use the letter T. Letter T for getting a parking ticket. So before the word and, we have N, and after the word and, we have T. Give me a second. All right. So look up. N comes before and T comes after and. So that means here I'm going to write N and T. Does everybody see that? Basically, I substituted those letters for here. And now, given that, we can fill out the rest of the formula. So tell your neighbor what those were. All right? What goes where? All right, Aaron, what goes here? What is it? T? And then? And down here? That is correct. So now that we have our setup, now we need numbers. Here we go. It says here, the probability of getting a no parking zone and a ticket is how much? 0.06, so that goes right here, 0.06. And then the letter N stands for no parking zone. So do we have numbers for no parking zone? Yes, no parking zone is 0.20. 0.20. All right, calculators calculate. Pass someone, Aaron. 0.3. That is correct. Or in fraction form, I'm going to say approximately 1/3. What does that mean? According to the problem, it says, find the probability he will get a parking ticket. So that means that 1 time out of what? Out of 3 times, he's going to get a parking ticket when he parks in a no parking zone. All right? Pretty straightforward. Yes, from 1 to 5, I'll comfortable are you with this? Yeah, 5, 5, 4s. Okay, send that in, please. Got it over there, Austin T. You good? Need some coffee over there? No? Austin T. You good? Great. All right, example super Q. For super Q, don't copy the verbiage. Start with the formula. Write your formula down first. So for this one, as you write your formula down, it says, example super Q, a box contains black chips and white chips. A person selects 2 chips without replacement. If the probability of selecting a black chip and a white chip is 15%, over 56. And the probability of selecting the black chip on the first draw is 3/8. Find the probability of selecting the white chip on the second draw given the first chip selected was a black chip. Okay, so formula, PB given A is equal to P of A and B over P of A. No, P of all right. So I'm going to forward the screen so you can actually write on the screen and label stuff so you can fill in those formulas. It's like Max is almost done. Very good, Max. All right. So, question. Did you see the word given in this word problem, guys? Now wait for this. There's a word given. However, let's start this one like we did the previous one. Do you see the word and? The word and. Yes? Yeah, right here. So what came before the word and? Black chip. And what came the word after and? White chip. So with that said, tell your neighbor what goes what. And then Max is going to get us going here. Okay, so here's our and. All right, Max, what goes where? Okay, again, here's the and, right here, right there. Therefore, B and W. Which means what goes here? Pass someone. Coal. Yes, and down here? B. That is correct. All right. So with that said, we need a probability for B and W. Did they give us one? Black chip and white chip. Yes, it's how much? 15 over 56. All right. Did they give us a probability for black chip only? Let's see. Black chip. Yes. How much is it? 3/8. All right. So, although that looks a little bit funky in the sense that there's fractions over fractions, can we rewrite that? Of course. Let's do that. We got 15 over 56 divided by 3/8, or in other words, 15 over 56 times 3/8. Multiply that and see if you can reduce to lowest terms. Oh, my bad, I forgot to flip the second fraction, guys. It should be 8 over 3. 8 over 3. I did that to see if you guys were paying attention. Bah. So, you should have gotten 120 over 168. Is that correct? Divide by 2, that's 60 over 84. Divide by 2 is 30 over 42. Divide by 2, that's 15 over 21. And what else can I divide by? Can I divide by 3? Yeah? All right. So therefore, P, probability of a white and a black chip, or a white chip before a black, is 15 over 21 reduced, that's 5 over 7. 5 over 7. All right, send me your notes, please. See what you did. Example Matthew reads, a recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. The results of the survey are shown in a table below. So copy the table, please, only. And we're going to do A together, part A. All right, so copy the table and then copy the words for part A. I'll give you some time. Go. All right, here we go. So we're going to use this table to answer part A. Okay? However, before we do that, look up to the screen. Look at the previous ones that we've done. On the previous ones in our formula, we ended up fractions over fractions, or we had decimals over decimals, which we can change into fractions over fractions. Keep that in mind for this one, because we do need fractions over fractions. So, start off with our formula. P, B given A equals P, A, and B over P of A. So, P given P all right. So, question. We're doing part A. Do they give us a keyword there? Vianney, do they give us a keyword? Given, that is correct. So we know that given is this. So now we need a letter for whatever came before it and a letter for whatever came after it. So what came before that, everyone? Yeah, so I'm going to use the letter Y. What came after it? The respondent was what? So then I would write what? F. So that means in our formula it's Y, F. And that should help you fill this up. Is that correct? Yes, Mr. Q. All right. All right, tell your neighbor what goes where. Looks like Alessandra's got this. Very good, Alessandra. All right, Alessandra, what goes where in our formula? According to this, if we follow that. F and Y on top. That is correct. Let's go. So, with that said, I need a fraction for the top, and I'm going to do that in green. Look up. So we need numbers for when, or probability of female and yes. So look at the table. Tell your neighbor what fraction are we going to use for female and yes. Talk with your neighbor. What fraction do I use? Then Alessandra's going to pass someone. Alessandra, go. Carter. Very close. 8 is correct. Over 100, that is correct. 8 over 100. All right, so if that's for female and yes, what fraction do we use just for probability of just female? Talk to your neighbor, and Carter's going to pass someone. All right, good conversation. Carter, pass someone. Max, for female only. Okay, so female only. Well, let's go with 8. But 8 is for female and yes. So here's yes, here's female, and we wrote that over 100. What is it? That is correct, 50 over 100. Yes, completely yes is over here, over 100. So, let's rewrite this. 8 over 100 divided by 50 over 100, which is the same as 8 over 100 times 100 over 50. Let me take you back to elementary. Cross cancel these hundreds, so that leaves us with 8 over 50, which is 4 over 25. So, we did that one together from 1 to 5. How comfortable are you with this? Using the table, 4 5s, 4 5s. So that means you're going to do part B by yourself. There's part B. The respondent was male, given that the respondent answered no. So do part B by yourself, and then send me your work, please. Those of you that are following on YouTube, make sure you get your practice in. The code was given at the beginning. See you guys next time. Peace.